Yeah, so the third type of waveform we are going to discuss is triangular waveform. So in the triangular waveform, this is the required condition. This is again a discontinuous function and the limit is from minus pi to pi. So there are two values. One is f of x is pi plus x and another one is f of x is pi minus x. So now we should take the phi of x value and we have to replace the value of x by minus x. So it becomes pi of plus into minus x. So it becomes pi minus x. So we can see that phi of minus x is equal to xi of x. So see, xi of x value matches. So in case of phi of minus x is equal to xi of x, we have solved so many problems. The condition remains that the f of x is an even function, and we also know that in even function the value of Bn, that is Fourier coefficient Bn, is 0. We need to find the values for a0 and an. So this is the formula for a0, that is in even function the formula for a0 in the interval minus pi to pi is 2 pi pi from the interval 0 to pi f of x dx. See, this is the required solution that I have done. I am not going to say this step. This is very simple. If you want, you can note this down. Yeah, this is the formula for an in case of even function. I have written it. I have substituted the value of f of x. I have kept the first function as it is into the integration of second function minus differentiation of this function. Differentiation of pi is 0 and minus x is minus 1 into the integration of the integrated function. Then I have simplified this term. It becomes minus cos nx divided by n square from the interval 0 to pi. See, this is the further substitution. So finally we get the value of an as 2 by pi n square divided by minus 1 minus 1 to the power n. So again I have written the Fourier series. The value of a0 we got is pi. So a0 by 2 will become pi by 2 plus summation n tends to 1 to infinity 2 by pi n square 1 minus of minus 1 to the power n, or we can write it as 1 plus minus 1 to the power n plus 1. It's one and the same into cos nx. So this is the required Fourier series.
So this is your next question, that is obtain half range Fourier sine series when f of x is equal to x minus 1 the whole square in the interval 0 to 1. So again this corresponds to the interval 0 to L, and in sine series corresponds to an odd function, and in odd function we know that the value of a0 and an corresponds to 0 and L is 1 in this case. So the only coefficient we need to find it, that is Bn. So the formula for Bn is 2 by L 0 to L f of x sin n pi x by L dx, right? So now solve this. The value of L is 1 and f of x, it is x minus 1 whole square, right? We can even write it as a minus b whole square, that is x square minus 2x plus 1. Okay, so directly write that minus 2x plus 1 sin n pi x dx. The value of L is 1, right? So I am not writing it. So Bn is equal to 2 into, so again the same thing, apply the Bernoulli's rule. First function as it is into the integration of second function sin n pi x. Integration of sin is minus cos n pi x by n pi minus the differentiation of the first function, that is the differentiation of x square is 2x and minus 2x is minus 2 plus 1 is 0. Okay, into the integration of the integrated function, the minus cos, so it becomes minus sin n pi x by n square pi square plus, so it's of the form plus minus plus, right? I have told it. So the next we need to differentiate this function, that is differentiation of 2x is 2 and 2 is 0. So 2 into again the minus sign, so the integration of minus sign is minus cos, so minus of minus cos, so it becomes plus cos n pi x by n cube pi cube from the interval 0 to 1. So now Substitute the limits. First is the upper limit. So 1 square is 1 minus 2 into 1, that is 2 plus 1. So it's equal to 0, right? 1 plus, yeah, it's equal to 0 into minus cos n pi by n pi minus of 2 into 1. 2 into 1 is 1, and 2 minus 2 is 0 again, minus sin n pi n square pi square plus 2 cos n pi by n cube pi cube minus the lower limit, that is 0. So 0 square is 0, minus 2 into 0, only 1 remains, minus cos 0 by n pi. 2 into 0 is 0 and 0 minus 2, so it becomes plus 2. So yeah, so since it's minus, right, so minus into minus is plus, so it becomes plus 2 into minus sin 0 by n square pi square plus 2 cos 0 by n cube pi cube. So here we can cancel out some terms, that is 0 into anything is 0, so this term is 0, this term is 0, this term is 0, only 1, 2, 3, only 3 terms remain. Okay, so now we'll write it. Yeah, so I have written the remaining terms. So now let's solve this. 2 into the value of cos n pi is minus 1 to the power n divided by n cube pi cube plus 1 by n pi minus 2 cos 0 is 1 by n cube pi cube. Okay, so this is your required b power n. Okay, if you want you can take the common terms, that is 2 by n cube pi cube common in these two terms, and you can write these two terms separately along with 1 plus n pi. Okay, or else you can keep it as it is. This is your required bn. So now let's write the Fourier series. Summation n tends to 1 to infinity. Bn term, that is 2 into by n cube pi cube plus 1 by n pi minus 2 by n cube pi cube into sin n pi x by l. So this is your required Fourier series. So this goes your next question, that is we need to obtain the constant terms and first harmonics for the given data, that is for the given x and y values. So here we can see that the interval is from 0 to 2 pi, right? So the interval is 0 to 2 pi, and also we can see that the first and the last values are matching, it's the same. So f of 0 is equal to f of 2 pi. So the period here is 2 pi, since the interval is 0 to 2 pi. Since the first and last values are same, the last value is neglected, therefore the observations will be 1 less than the total count, that is the observations are 7 right here, so 7 minus 1, therefore the observations are 6 in this case. Okay, and again create a tabular column, entry the values of x and y. So in order to find the constant term we need summation y, that is summation of y, we need to sum these terms up. So what answer we get here? 26.9. Let's check it once again. 7.9 plus 7.2 plus 3.6 plus 0.5 plus 0.9 plus 6.8. Yeah, we got it as 26.9. Then again substitute the value of cos x 1 by 1, that is cos 0, cos 60, cos 120 and so on. After that y into cos x, that is 7.9 into 1, 7.2 into 0.5, we need to get the answer, 3.6 into minus 0.5. After that, in order to get the summation of y cos x, again sum these terms up. So the after summation we'll get it as 12.15. Again let's check it. Plus 3.6 minus 1.8 minus 0.5 minus 0.45 plus 3.4. The answer we get it as 12.15, right? Again for sin x, same thing. Y sin x, we get the answer as 2.6746. Okay. After that, again the same thing, we need to find the values for a0, a1 and b1. a0 is the constant term, and for a1 and b1 is used to find the first harmonics. So 2 into summation of y by n is the formula for a0. Here 2 1s are, 2 3s are. So the required answer we get is 26.9 by 3, right? The answer is 8.966. It's recurring, so let's stop it at 4 decimal places by adding 7 here. So 8.9667. So here a1 is equal to 2 into summation of y cos x by n. So here the value of n is 6, right? So 2 1s are, 2 3s are. So the required answer we get is 12.15 divided by 3. The answer is 4.05. Correct, right? So again for b1, that what is the answer we got? 2.6746. 2.6746 divided by 3. Yeah, the answer is 0.8915. After that, write the first harmonics. The formula is a1 cos x plus b1 sin x. Substitute the values of a1 and b1. Write the first harmonics. After that, if you want, you can write the Fourier series as well. That is a0 by 2 plus the first harmonics. So this is your required Fourier series. Okay. So if you want, you can write the Fourier series, or you can stop at this stage itself. Okay. Because they have in the question they are not asked to calculate the Fourier series also. They are told only to find the constant term and first harmonics. The constant term is this one, a0, and the first harmonics is this one. Okay.